Hello friends, welcome back to my channel Q Analysis. Please don't forget to subscribe to my channel for more videos on quality analysis and testing, and do share it with your friends, and don't forget to hit the bell icon. Let's go ahead with our today's presentation. Today in this presentation of mine we are going to discuss about test automation. Know it before you start it. I keep on getting a lot many questions, queries from my fellow testers, and they ask me certain questions regarding automation, and which I seem to be very genuine ones. So I decided to come up with this automation video presentation, and I hope I could help you people with your queries. On the next slide, we'll discuss about the agenda and the kind of topics which I'm going to cover as a part of this presentation. But before moving to the next slide, let's see what is test automation. Test automation comprises of different steps altogether which lead to test automation feasibility study, evaluation and selecting of the tool. Then you have identifying the automation framework related responsibilities, performing proof of concept, and developing automation framework, and reviewing the automation test script. All of these steps together, all of these phases together, they form a test automation suite, or something which is known as test automation. When I say feasibility study, we figure out, okay, the kind of effort in terms of resources, in terms of budget, in terms of time, what we are going to put. Is it going to return any kind of value to the users or to the business or to the testing team or to the development team? So that is a kind of feasibility study. Next to it, we evaluate different kind of tools. Every project has got their own requirement. They have different technologies, and depending upon the technologies, you need to select the tool which is best suited to your requirement. Next to it, you have to figure out a suitable automation framework. I'll discuss about the different kind of framework in my coming slides. Then we talk about the proof of concept. We develop a small proof of concept, a small working model which shows how exactly the automation framework will work and what kind of things it is proposed to do. Depending upon this POC, a proof of concept, a complete automation framework is developed from scratch, or maybe by reusing some of the concepts or some of the code. And then finally, the automation test scripts which are developed, they are reviewed and tested. So before you roll out them for the final production version or testing the production version, you need to test your automation script and make sure that they are running fine and your script is bug free, and it is actually finding bugs which is supposed to do. So this is what is test automation. Let's move on to our next slide, which is about the agenda that we are going to cover today. We'll talk about the automation approach, different kind of automation approaches, how to interact with the system under testing. When we automate, how do we interact with the system under testing, and when to automate and by whom to automate, who is responsible for automation, and when should we start with automation. Automation supporting practices, different kind of practices that are required for supporting automation. What are different kind of automation tools which are available and which could be used by team for automation purpose? What are different kind of skills that are needed by testers, developers, or anybody who is interested to do automation? And final, we need to figure out, okay, which way to go, manual or automation, or why manual and why automation. So these are the topics which we are going to cover in our today's presentation. Automation approach. Automation approach is the kind of approach what a automation tester is taking in order to automate the test cases. Those are functional or better to say manual test cases which are to be automated. They can be automated using record and playback, or by scripting, that is linear scripting. You can have modular approach, so it is known as modular scripting. You can have data driven testing, or you can have keyword driven testing. So You can perform different kind of automation approaches. You can use different kind of automation approach. Let's see one by one what are those. Let's see first one, that is record and playback. Record and playback, I remember long back there were certain tools like QTP wherein you can just record and run whatever actions you are doing on a screen. Just click record button before doing it, and once you are done with the actions, just click on stop. It will generate objects, test objects, and it will do exactly the same thing what user did. So this was known as record and playback. Capture the interaction with the system and replay it. It was very popular long time back, and even now many tools they use it. But then I think all those commercial tools, they want to make things very easy for you, but then it requires a cost. It's not free. They do it for you, and in turn they charge you. Second approach, before moving to the second approach, we can see record and playback example. So opening HTML, putting some values in the username field and putting the password value, and then clicking on the login button. So you can see all these actions are being recorded, and they can be done again as you click on play. Record and play. This was example for Selenium IDE that also supports record and playback. Record and playback approach is a benefit. It is very easy. So even if you don't know automation, you're a normal tester, you don't, or a developer, or you're a business user, you don't know anything about testing, you can go ahead and automate what exactly a user wants to do. It's mainly used for the UI based applications and front end. It's very easy and fast to create initially. No programming skills are required. The drawback or the problem with record and playback system is they don't test anything unless checkpoints are added. You need to add checkpoints. They're very fragile. If at all there is a very change in the XPath or location or UI, anything is changing, they will break. They are not going to work. They're very hard to maintain. They're not flexible. They cannot be maintained. A single point of change will break out your whole script. No modularity or no reuse can be done. System must be ready before automation can start. That is the biggest drawback. You have to have a system always ready. So you cannot take just a portion of system and keep on testing it. Does not support acceptance test driven development, ATTD, which is agile test driven approach. And then we can say in short that record and playback approach is seldom good approach in general, never too good for large scale automation. The second approach is linear scripting. In this approach, a non-structured script interacts directly with the system under testing, and you need a little bit of programming skills. It can also be produced by record and replay tools. So what exactly we do? We have, so for every action, for everything, we have certain steps, and those steps are written either by programming or they are recorded, and whatever interaction you do with system under testing, they are being recorded under linear scripting. This is very basic example of linear scripting. You can see you're starting a Firefox with some local host, and then you're giving your URL, and then you're opening the HTML page, providing login password, and clicking on login button and seeing it with checking whether you can see the welcome page. If welcome page is there, mark login pass or else login fail. Linear scripting has got benefits. It's fast to create initially. It's very flexible. It's simple, and you can create small functions. It can use common scripting languages, and most of the time they are free and you don't need any license. You can do it in any programming languages, which allows you to script. So write from VB script to JavaScript, Python, Perl. You can do it anywhere. That's not a problem. Linear scripting has got a few problems, like creating tests require programming skills. They too are fragile. One change in system may break all the script, and they're hard to maintain. Plenty of test script and no modularity or reuse, because for every action you have a script running, so it's not very easy to maintain it. Summary of linear scripting: educate for simple tasks, never a good basis for a large scale automation. Modular scripting. Now, modular scripting is something like you have a linear script you have created for few actions, you have created a script, and then you keep on reusing those scripts so that they become modular. For example, I have a system wherein I have to log in, and after login I have to check that my login is successful, and again I come back, log out, and then re-log in, and if I'm using an incorrect password my login will fail. So now it has three different actions: login, log out, and checking. So if we have three different, in linear approaches we'll be having three different uh, scripts, but over here we can have one test case which will use all these three scripts together, and it will become a modular scripting. This was just an example. Similarly, if we keep on going to the next one, like if a user has two login IDs and through one he is logging in, and after logging in another browser he is trying to log in using second login ID, since one session is already in progress, he should not be allowed to log in using the other session on the same browser. So this is a kind of test which you can do, and many of the test cases can be reused, many of the scripts can be reused, and it becomes a modular approach. Modular scripting example, you have an example over here which talks about a URL, a login ID, user ID, and a password, and you go and you check your login and you check the title, and then you can see your login, password, title, and your welcome page, and if it is working fine or not. And for everything you have created a separate set of function. So most of the time what you do, you have a test library wherein you create in several scripts, and then you have a driver script, and in this driver script you keep on calling function as and when needed, and all this function in turn you pass in a parameter, you call the function, and this function will use the same script, and as and when you need a script it is being called and used for your automation testing. Modular scripting benefits: reuse of code. It is highly modular, creating new test cases is fast and easy. Changes require fixes in smaller areas. It is highly maintainable. And then driver scripts are very simple. All you need to do is calling driver script, and depending upon your test cases you can change the stuff. It's not a problem. Creating new ones is not a hard. Modular scripting problem: building test library require some initial effort because you have to automate every action and step and keep on making a lot many library and test cases. Once you have it, you can use it as and when you require. Takes little bit of time. It takes time, requires programming skill. Test data embedded into a script requires some understanding of programming. New tests require new driver scripts, maybe, depends upon you. But yeah, most of the time, depending upon the complexity, you'll be requiring a new driver script. Modular scripting summary: good for simple tasks, works also in larger users if everyone who needs to understand test can program, and not good for non-programmers. That's for sure. Now the other approach we will talk about is data-driven testing. In data-driven testing, we have data which is used for testing, and scripts, they are based upon data. Always we have an input, and depending upon the input, the script, they keep on functioning. The function we pass in data as a parameter, and that drives the test cases. They can be customarily presented in tabular format. One driver script can execute multiple similar test cases, and new driver script is still need to different kind of test. You can see here one set of test data, and then you keep on passing it, keep on creating new set of test data. Driver script is there, and keep on calling the function, passes the data, and so on. So now when you know about data-driven testing, let's see an example of data-driven testing. So here you can see we have test cases, add 01, add 02. These are the numbers, operator, number, and expected result. So you can just relate with this image. We have a data set, and then we have function, and depending on the function we need to have some output, and we already know whether this output is going to match. If not, after this operation whatever result we are going to get, that should match with this one. If not, then test case will fail, or else test case will pass. This is the way we do data-driven testing. Data-driven testing has got its own benefits, like test libraries provides a lot of modularity. They are very modular and you can cover a lot many cases. Same benefits with modular and the same benefits as with modular scripting. And then creating and editing existing test cases is editing the existing test cases is very easy. No programming skills are required because most of the time you have everything in the Excel sheet or data sheet. All you need to do is to define the operation, which is not a big deal. For that you have system defined functions, so it should not be a big problem. And then maintenance responsibilities can be divided. Testers are responsible for the test data and programmers are responsible for the automation of code. Hence, it's a mix and match kind of approach. Data-driven testing had its own problem. Let's talk about a few of the problems. Like test cases are very much similar. For example, 1 plus 2 equal to 3 and 1 into 2 equal to 2. So this is arithmetic operation. So this test cases are very similar. New kind of test cases will need new driver script. For example, 1 into 2 plus 3 equal to 6. Now it has got Bodmas, the precedence operator precedence plus equal to symbol operation. So it has to figure out what exactly has to be done and then what is the precedence and how to calculate the value and whether the value is matching to the expected or not. So it will require a little bit of coding and then a separate set of driver scripts will be needed. The same driver scripts cannot be used here and here. It depends. Creating driver scripts requires programming skills which is done by the developers. Sometimes it can be done, it's not very tough, it can be done by testers as well who are good in programming. Initial effort in creating the process and other reusable components can be pretty big. Now let's come to the data-driven testing summary. This approach, data-driven testing approach, is good solution even for large-scale use. New kind of test requiring programming is a minus. So we know that it requires a complete set of programming and maybe overkill for simple need. It can be overkill for simple need because if somebody is doing some normal arithmetic, you can write in macros. You don't have to go ahead and do this data-driven testing on large scale. So now our next approach is keyword-driven testing. Keyword-driven testing is something like you have set of test data and then you have a layer of test framework, and that test framework uses the test library which in turn is based upon keywords. So not only test data but also the directives keywords telling you how to use the test data, taking out of the test scripts, and then keyword and the test data associated with them perform the test execution, they drive the test execution. We'll see an example over here. So this is test case for login. So valid login, this login is valid or not. It can be checked by open browser to login page, open browser to see the login page, and then input username equal to demo, input password equal to mode, and then submit credentials, submit login and password, and welcome page should be open. If it is, then it is passed, and then close the browser. So this is a valid login scenario. If any of these steps is failing, then it's a failure scenario. This case is failing. This is an example of keyword-driven testing. Keyword-driven testing has got its own benefit. Most of the time it is similar to the data-driven because they are very much similar. The only difference is over there you have data, over here you are having keyword, and more or less they are used in the same way. Non-programmers can create and edit test. Separation of test data and code is like we have two different. We have test framework which will have test libraries, and we have a data set which will have data. Test can be constructed freely from keyword. Most of the time you just write in the keyword for which the action will be performed. So test can be created freely from keywords. Non-programmers can create new kind of test. It's very easy for them depending upon the operation what they do. If they know the business function, they can go ahead and create a test with suitable keywords. Data-driven testing is also possible, as I told you. Data-driven testing and keyword-driven testing are very much similar and interrelated. They can be used in close proximity. All tests can be executed by one framework. We have seen the framework like over here. You have data, you have test framework, you have test library and system under testing. So test framework, it uses data and it uses the keyword. In turn, it takes the test function from the test library and uses the system under testing for testing purpose based upon the data and the test cases scripts which have been automated. Tests can be executed from one framework. No need to create and maintain separate driver scripts. So that is the good part of it. And let's talk about the negative part of keyword-driven testing. That is the problems. Initial effort can be really high, but there are open source tools available, which we'll talk about what are different kind of open source tools, which I will cover it up in my upcoming slides. Now let's talk about the summary. Keyword-driven testing summary. This approach is very good solution for large-scale use. Use the existing solution if you can. It's pretty nice because it can use a lot more solutions. So if you have something, just go ahead and use it. Maybe it can be an overkill for the simple need, but still I suggest it's good for the bigger organization. With this, I'll end up the first part of my presentation. Thanks for watching, friends. If you really like my video, don't forget to subscribe, like and share my channel. And I'll soon come up with the second part of this presentation and we'll discuss the remaining topics over there. Thank you, happy learning and happy testing. See ya.